Hello, good afternoon, students. Good afternoon to all of you. Welcome to each and every one of you guys. It's almost 3 o'clock. We're going to start the class in another couple of minutes. So I'm just launching poll. Please, everyone, try to answer. Am I clearly audible and is the screen is visible to each and every one of you? Just let me know, guys. Good afternoon to each and every one of you. Good afternoon, Venkat. Good afternoon, Soumya. Good afternoon, Srava. Good afternoon, guys. Please answer me. Am I clearly audible and inform your friends to join the class, everyone. Good afternoon, YouTube live students. Inform your friends to join the class, guys. Everyone just inform your friends to join the class. I can still see very less number of students have joined the class till now. Please inform them, guys. Okay. Okay. No, Venkat, it's not over. We have to solve questions, right? We have not solved questions based on mutual inductance. Venkat, it's not over. Mutual inductance is still yet not over. Okay. You have to solve questions. We have not yet solved questions. Please inform your friends, guys. I can see only 30 students are there in class. This is, I don't know why. Good afternoon, Hema. Good afternoon. Good afternoon to each and every one of you guys. Please inform your friends to join the class, guys. We're going to start the class in another 1 minute. I'll not wait too much long. Okay. I can still see most of you are still joining. Sir, from where you are taking the classes? Taking classes. I'm taking classes from my home. Okay. States. Jharkhand. It's Jharkhand. Venkat. What about reopening? I have no idea about reopening. Hema till now. I have no idea about reopening. Okay, guys, I have waited along and I can see that most of you are saying that I'm clearly audible and screen is also visible. So let us start our today's class. Okay. See, so what exactly? No idea, on this. I have no idea about reopening. I can't guess also. It's really tough because we don't know how the COVID situations are gonna come this week, this month, or might be next month, right? So we can't risk our life. Okay, so yeah. So good afternoon, YouTube live students also. Please be there on time, guys. If you're not there, I can see no utilized students. No idea. Okay. So we will start our class, guys. So as most of you are saying I'm clearly audible, that is really good. So basically in today's class, what we'll be doing is, we will be trying to solve the homework question. First of all, what I gave you yesterday. So those yesterday's homework questions were totally based on the conceptual understanding of mutual inductance and self-inductance. Okay. So don't worry, we might be tomorrow or day after tomorrow, we'll be having questions in which we'll be taking questions from mutual self, okay, and module questions. Okay, so today's class, what we'll be dealing is, we'll be trying to solve those homework questions. Okay, we'll be trying to solve the homework question. We will be also trying to, I have sent it one video. Have you tried to watch that video, guys? I have sent it one video yesterday in the group. Have you tried to see that video? It was only of 2 minutes, right? Magnet one, yeah, correct. So you might have seen that when the magnet was passing from that copper coil, so it was not stucking over there, right? It was trying to go down in a very slow pace. And the reason why he's going down in a slow pace is, can you tell me the reason why he's going down in a slow pace? Because there is some kind of induced EMF producing over there, right? And due to the induced EMF, there will be very good eddy current. So I think so. I have talked about eddy current in our last class in starting only. Very good, guys. I have also put it the video over here. Don't worry. Okay. Then today's class will be basic after homework question. That is, homework questions will be based on self and mutual inductance. Yeah, I have kept like nothing, but we have started with LR circuit. Don't worry, LR circuit is not a very big topic in this chapter. LR circuit is one of the smallest topic in this chapter. LR circuit will be bigger topic in next chapter. That is your AC. Okay, your next chapter name is alternating current. So in that LR circuit will be going much more deeper. So in this chapter, you will be having a basic idea, how much idea you have got about RC circuit in capacitor chapter. Like that, you will be giving you basic idea about LR circuit concept. Now there are two conditions coming in this LR circuit, that is growth and decay. So we'll be understanding that. I hope you have also learned the growth and decay of RC circuit, right? So you can treat growth as charging, guys. So growth is somewhat looking like charging and decay is somewhat looking like discharging. So we have learned about charging and discharging of capacitor. So it is just like charging and discharging of an inductor. Okay. One more point I want to add over here, like, so you know that resistance is used to uh, mm, basically oppose the current, right? And you got to know that capacitor help us to store the energy. Okay, so let me tell you one more important point. Actually, inductor, when we talk about inductor also help us to store the energy. Okay, inductor also help us to store the energy, but in which form? So capacitor helps to store the energy in the form of charges, right? Store the energy in the form of charges. Can you tell me inductor store the energy in which format? If you can try, that will be really good, guys. And inform your friends to join the class. I can still see very less number of attendance. I don't think so. Your friends are taking it seriously. When it will be there from your principal side, then it will be more seriously. No EMF, not EMF. Good. Venkat, you've tried well, but that's not correct. So inductor, guys, inductor used to store energy in the form of magnetic fields, not current and not EMF. Those are the property of an inductor. They try to show EMF and they try to produce current, right? But actually they try to store energy in the form of magnetic fields. Okay, is it clear? So this is one of the important topic that I wanted to let you know. Okay. Now we will move ahead with our homework question, guys, as we have discussed with our content. So in our homework question, the first question that I have kept in front of you was the question. So this was the question that I kept in front of you, right? Question number 1. So what was the answer that you have got over here? So as you can see, have you tried to get the answer? Can you tell me the answer? How much is the value? So few students are saying minus 4 volt, few students are saying plus 4 volt. Why there is some kind of confusion like that? I'm not getting. Why there is confusion? Means how can you give me two different answer? When 1 is equal to 1, then you cannot say minus 1, right? So you should be very clear from your side that whether I'm writing plus or whether I'm writing minus. There should be no such kind of confusion coming into your picture, right? So when you're talking about the EMF, right? So generally we'll be taking, when we write EMF, we used to take mod. That is what I'm teaching you from last class and before last class also, right? So we'll be writing nothing but mod of L di by dt, mod of L di by dt, right? Now, if you're writing mod, you know the value for L, guys. So the value for L is nothing but it has been provided is 2 Henry, right? Multiplied by di by dt. But because they have given di by dt as negative, but what does this mod is doing? This mod will make them as positive. So we'll be multiplying this with nothing but 2 ampere per second. Am I right, guys? Is this clear? So how much is the answer? The answer that you'll be getting is nothing but 4 volt. That is mod of EMF. Mod of E, you will be getting nothing but 4 volt. Is it clear to you? Please let me know. Is it clear? Harisa, you have given me the wrong answer. And Srava, is it clear now, Harisa and Srava? Yeah. Now, when it comes to the direction, guys, you can see that over here, the inductor is going something like this, right? The inductor is going something like this, and the current in this inductor is going in this direction. But the current over here they have given is it increasing current or is it decreasing current? How can we tell that? By seeing the rate only we can tell, right? So if you're gonna write di by dt, so they have given di by dt as minus 2 ampere per second. So from the sign only you can say and tell that the rate is negative. So that's why I can say that it is gonna decrease. And once you get that information, so this current is decreasing. This current is doing what? This current is decreasing. So in order to find the direction of EMF, what you need to do? You need to oppose him, right? You need to oppose him to find the direction. You need to oppose him. So what is the opposite of decreasing? Everyone know the opposite of decreasing is increasing. So you need to increase the current. So how can you increase the current? I cannot increase the current by giving in opposite direction, right? If I want to increase the current, I need to give in the same direction. So it is very clear to have a clear understanding that I need to give the induced current in the same direction. That means induced current will be produced in the direction of current only. Is it clear, guys? Please let me know. Are you clear with the direction of induced current? Is it clear? So the direction of current will be from P to Q. You should be very handy to understand this, right? Now we will move to the second part. If I want to replace this, how can I replace this, guys? If I want to replace this with a battery, how can I replace this? So if I want to replace this with a battery, you can see current is going from left to right. That means positive terminal will be there on the left hand side or right hand side. Please let me know. If the current is going from left to right, you should be very clear to say that obviously the positive terminal will be there on the right hand side only, right? So I'll be drawing diagram for you. So you can see the positive side is out there on the right hand side, and the negative terminal is there on the left hand side, and you're going to connect this circuit with nothing but a normal wire. You're going to write this positive, you're going to write this negative, and this is the reason why induced current is going in this direction. Is it clear? Please let me know, is it clear to each and every one of you? So you can replace this inductor with a PQ with a battery, which you can replace with positive and negative terminal. Is it clear, guys? Is it clear? If it is clear, then we can proceed to next problem. This was the first homework problem that have been given to you, right? Good, good. Please inform your friends to join the class, guys. Everyone. Okay. So we're going to move to next question. If you have understood this problem, then we can move to next problem. Just a minute. Yeah. So can you tell me the answer of this problem? If you have got any kind of answer, you can share with me, guys, if you have got any kind of answer. Okay. Okay, just a minute. Yeah. So please tell me the answer of this problem, guys. This was the homework problem that I gave to you. Have you tried out this problem? In this problem, they are saying that there are two concentric circular coils are there. So this is my first coil, okay, and this is my second coil. So there are two concentric circular coils. They're asking me to find the mutual inductance due to the pair of these concentric coils. So can you tell me how much is the answer? So the first coil is having the radius as R1, and the second coil is having the radius as R2, right? I have two radius. This is my first coil, this is my second coil. So what I call my first coil, guys? Please let me know. What shall I call my first coil? Please let me know, guys. Very good. So my first coil will be called as primary coil. What I will be calling my first coil? I'll be calling my first coil as primary coil and the second coil as secondary coil. Very clear to understand, guys. Lots of students get confused over here just because they have written 1 and 2 and you have mugged up in the formula of primary and secondary and you cannot able to find where is 1 and 2, right? So don't go like that. Understand what is the things are there. Okay. Now, once you have understood this, so what exactly is happening? You can see that the first coil is also there and inside the first coil, the second coil is there. So can I say that second coil is inside the magnetic field of first coil? First tell me, guys. Can I say the second coil is inside the magnetic field of first coil? I can very clearly say that my secondary is inside primary, but I can write my secondary is inside primary, right? Inside primary. So if I can say like that, my secondary is inside primary. First of all, let us try to find how much is the value for, very good, Sarava, that is the correct answer. How much is the value for the magnetic field, right? So magnetic field due to the primary coil, or due to the first coil is how much, guys? Can you tell me the answer? How much is the magnetic field due to the first coil? Everyone should remember this. Mu naught I by 2 times of, please tell me how much will be the value. Mu naught I by 2 times of R1, right? Mu naught I by 2 times of R1. So there we have assumed that the current is flowing in this direction. This is just a normal assumption. It should not be like, sir, I have assumed in opposite direction and I'm not getting answer. It's not like that. So you have just assumed that the current is flowing I1 in the first coil and the current is flowing in the I2, that is induced current in the second coil. So you have nothing but mu naught I1 by 2 times of R1. This is nothing but the magnetic field given by the first coil. Once you got the magnetic field, now I will try to find the flux due to the first coil. So how much will be the flux due to the first coil? Or instead of talking about flux, let me talk about the flux due to the second coil. So what can I write, guys? Flux due to the second coil. If I want to write flux due to the second coil, you know the formula for flux. Flux formula is nothing but, yeah, if you go in opposite direction, you will be getting same answer, Hema. That is not a problem. Okay, so flux due to the second coil will be equal to nothing but B dot A, right? B dot A, right? But the concept comes over here. So shall I take the magnetic field of second only, or shall I take the magnetic field of first? Tell me. So initially there was no current in second coil, guys. There was only current in first coil. So there was the magnetic field that was only there in first coil, and second coil is inside that magnetic field, right? So we will be taking nothing but we'll be taking flux is equal to flux due to second coil will be equal to magnetic field due to the first coil multiplied by. So shall I take the first coil area or shall I take the second coil area? Please let me know. You have got cleared about that why I'm taking the magnetic field of first coil, because there is only magnetic field of first coil. There is no magnetic field for second coil because it has not been produced yet. It is just been kept like that, right? The area will be there of second coil. So this is what you need to understand. If in the same problem they would have given the opposite, right? So if primary is inside secondary, then the whole way and nature of solving question will change. I hope you are getting. Then you will be writing B2 multiplied by A1, right? You won't be writing B1 multiplied by 2. So guys, this is not a formula. This is a concept. Let me tell you. So you cannot put this in every question and say that, okay, I can solve it. Okay, this is a concept that you need to have in mind, and then you have to replicate how the things will go on. Okay, so you can see that I'm trying to write flux due to the secondary coil, which will be equal to nothing but, since there is no magnetic field due to the secondary coil, so that's why I'm taking the magnetic field due to the primary coil, and the area of the secondary coil I know, right? So I can write A2. So tell me how much is the magnetic field due to the first coil. I have find it out the value. So the magnetic field due to the first coil is nothing but mu naught I1 by 2 times of R1. What is the area of the second coil? Everyone know area of a circle. So area of circle is nothing but pi R2 square. Pi R2 square, right? So this is the area. So this is the value for flux, right? In this problem, they are asking me how much is the mutual inductance. But they're asking how much is the mutual inductance. So what is the formula for mutual inductance, guys? Please let me know. Pi R1 square. Why are you writing pi R1 square? May I know, Venkat, what is the reason of writing pi R1 square? No, right? Pi R2 square. Good, Venkat. Good. So tell me, guys, if I have got to know about till here, they're asking mutual inductance. So what is the formula for mutual inductance? So flux is equal to MI. So could you remember the formula for mutual inductance that we have learned in last class? If you can remember, that is the reason why I gave you this problem as a homework, guys, so that you understand it in a better way. Okay, it should not go like in opposite. So what you can write? You can write flux due to. So it is very mandatory to remember that which is flux and which is current. So if you are writing flux due to second, then it should be current due to first, right? If you are writing flux due to second, then you should write current due to first. If you are writing flux due to first, then you should write current due to second. So there should be no such kind of confusion. So flux can be also written as Mi. So I can replace this flux over here, right? So over here, the flux is given, flux due to 2 is given by mu naught I by 2 times of R1, I1 multiplied by pi R2 square. This is same value I have written. This is the same value. Now I can replace this flux by nothing but M multiplied by I1, which will be equal to mu naught multiplied by I1 multiplied by pi times of R2 square divided by 2 times of R1. You can very clearly see over here in this that I1 and I1 are getting cancelled. So you will be only left out with one part, that is mutual inductance. So mutual inductance M will be given by mu naught times of pi R2 square divided by 2 times of R1. Is this is clear to you? Please let me know. Is this is clear to you? Please let me know. So as you can see in the diagram or in whatever we have got from the term, that does this value looks constant, guys, or it is variable? So you can see radius is constant. Obviously radius is not going to change. R1 and R2 both are radius, both are constant. Pi value is constant, that is given by some scientist 22/7. Mu naught value is also constant given by some scientist, relative permeability of free space, right? So you don't have value for mu naught over here directly. You don't know direct value of mu naught, but you know one thing, guys. You know mu naught by 4 pi value. You don't know direct mu naught value, but you know you can remember mu naught by 4 pi, which is equal to 10 to the power minus 7. So you can utilize these all things and try to solve the problem in an easier way. If they ask you in the number, give me the answer in number type, right? If they would have given you the radius is 1 meter, radius 2 is 2 meter, find out the value. Are you getting my point? So don't get confused over here by for solving the question just because you don't know the value for mu naught and it is not been provided in the question. They expect from you that you know mu naught by 4 pi, and from there you can get the value for mu naught. Is it clear, guys? Is this problem is clear to each and every one of you? So this is one of the homework questions that I gave you in last class, guys. I hope you can see that how we are utilizing the value for mutual inductance. Don't worry, from mutual inductance, they are not going to ask you very different kind of question. They're going to ask you some kind of questions which is related with this. Else, they're going to ask you with the questions of transformers. I have not introduced transformer yet. Might be tomorrow, or if there is class on Friday, then we will be discussing about transformers, that is AC generators. All are correlated. Yeah, good, Emma. Everything is correlated. That's why we say that class 12th is bit easier than class 11th, because class 11 we don't know anything, we're learning first time, and class 12 we got experience of 1 year. Now we know things happen like that, so we have to learn and implement it. Okay, so anyone is having any kind of doubt in understanding this? Normally we have tried to find out the flux, we try to find out the value. If it is clear, then we can proceed to next problem, guys. Okay, good. It seems, sir, but mine's, mine's 11th 00. No problem, Nandis, no problem. We'll be also, see, at least you should be confident of first ever chapter of class 11. Okay, we know that we have not done the other chapters of class 11, but we have done almost from chapter number 1 to chapter number 7 we have completed for you. So try to make sure that okay, I have completed with the chapters of 12th and first 7 chapter of class 11. The rest 7 chapter are left out, that we will be dealing after class 12. Is it clear? So that then you can be very confident that these are my strong topics, I can work on it, and these are my weak topics, I can work on it. Okay, so let's move ahead, guys. Let's move ahead to the next topic, the next question actually. So this is the third homework problem that I have given to you. Sir, after 12 uh, by the end year, next what, sir? No, your 12th syllabus will be completed in September, might be October starting. There's a huge possibility. Okay. See, now August is going on, right? Might be September end. We'll be trying to complete, because we don't have left out with lots of things, guys. We are only left out with ray optics, wave optics, and modern physics. These are the 3 important parts that is still left out. Okay. Yeah, Nandis, no problem in this. Dual nature. Yeah, that comes under ray optics and wave optics are only the dual nature. Okay. The dual nature, modern physics. So there are 3 chapters in NCERT for modern physics, but we have only 1 chapter, so we will be colliding them. Okay, so what was the answer for this, guys? Have anyone of you have got the correct answer for this? If you have got, then it's really good. Yeah. So tell me the answer for this, guys. This was also problem that I have given you as a homework, and I expected you that when you go home you try to solve it and then you get the answer. Okay, but have you tried it out? It is also an easy question, guys. In this question, they are saying, I have also given you the hint. So in this question, actually, there are 2 loops or 2 coils. You can see that this is one of the coils. I'll try to make the coil a little bigger. Okay, which looks good actually. So this is one of the coil actually, guys. Okay. Okay. And there is one more coil that is inside of it. Okay. So the inner coil is having the inner coil. So what we will, oh, I'm really sorry. Yeah. You are nearby. That is really good, Srava. So you can see that they have given for the inner coil, the length is L, the radius is R2, and the number of turns per unit length is N2, guys. Similarly, for the outer coil, they have given, I'll be using blue color. So for the outer coil, they have given the length is same, guys. The length is not changing. And the radius is nothing but R1. And the number of turns per unit length is nothing but N1. Right? So if these all things are understandable, guys, then Then, so which one should I, so before you solving any question of mutual induction, first try to find which is a primary, which is a secondary. So which one I said I can take primary and which one I can take secondary. Tell me guys, shall I take the inner one as secondary and outer one as primary? Will it will be comfortable with me? Will it will be comfortable with you? Yes, it will be the most comfortable point to solve this problem. Okay, if you're gonna take the inner coil as secondary coil, okay, and the outer coil as primary coil, then it will be really a very comfortable way to solve this question. Let me show you how. Because initially both the coils were there, right? So I am trying to give only current to the first coil. But I'm trying to give only current to the primary coil. So if there will be only current to the primary coil, let me write the current as I1. So will there will be any kind of current induced in the secondary coil? Yes or no? If I'll be giving a current to the primary coil, will there will be any kind of current or induced current will be produced in secondary coil? Yes, that is what mutual inductance is there, right? What is N2 by N1? I don't know about N2 by N1. What is N2 by N1? There is nothing, there is no thing called N2 by N1, okay, Arun? Okay. Now try to understand over here, Arun. Okay. So you got to know about this coil. So first what I'm trying to do is in the primary coil, I'm trying to put current. If in the primary coil, if current is there, obviously the magnetic field will be there. And secondary coil is inside that magnetic field. So first of all, I will try to write the magnetic field due to the, I will try to write the magnetic field due to the primary coil. So B1. So what is the magnetic field due to the primary coil? Tell me. Please let me know, guys. What is the magnetic field due to the primary coil? Please let me know. Magnetic field due to a solenoid, you have learned this. I don't have to repeat again and again, right? So magnetic field due to the primary coil is given by mu naught, and the number of turns per unit length is nothing but N1, and the current which we are treating over here is nothing but I1. So mu naught Ni. That is what we have learned, right? Mu naught Ni. Very good, Sravan. Right? So this is the magnetic field due to the primary coil. Now now the second step, I want to find the how much is the flux produced in the secondary coil. So flux produced in the secondary coil is given by magnetic field multiplied by area, right? So my magnetic field is nothing but magnetic field. Shall I take of first one or shall I take of second one? So it is very clear to understand from here that there is no magnetic field produced by the secondary one, right? In starting, the magnetic field is only produced by the primary one only. So you're going to write magnetic field due to the primary one multiplied by the area, right? Multiplied by the area, right? So what you can write over here, area of the secondary. Right, students? So if you're clear till here, now you try to put on the values. You try to put on the values. So what can I write? So I can write the magnetic field due to the first one as, the magnetic field due to the first one is given by mu naught N1 I1 multiplied by area. So what can I write? Area of a single loop, guys. Let us talk about area of the single loop. This is area of 2, okay? This is area of the secondary coil. So what is the area of only one single loop? Area of only one single loop is nothing but pi R2 square, pi R2 square, right? Pi R2 square. So this is the flux due to the single loop. This is the flux due to the single loop. Am I right? This you are getting the flux due to only single loop, pi R2 square. Now for total flux, how much will be my total flux if I try to write total flux? So total flux through 2, I will write like this. Total flux through 2 will be equal to nothing but total number of turns. So how much is the total number of turns in the secondary coil? Tell me. So you know the total number of turns per unit length. They have given N2. N2 is nothing but number of turns per unit length. Number of turn per unit length. Per unit length. Right? So N2 can be written as nothing but N divided by L. Right? N2 can be written as N2 divided by L. So what can I write? I can write number of turns, total number of turns, that is capital N2 should be equal to nothing but small n2 multiplied by L. Small n2 multiplied by L. So total number of turns will be how much? That I will try to write the total flux, right? Total number of turns will be how much? So total number of turns will be nothing but small n2 multiplied by the total flux. How much is the total flux? Is it understanding, guys? Is it understanding? Are you understanding this? Very good, Nandis. You have tried to get the answer. That is really good. So put on the values, guys. N2 value is how much? N2 value is small n2 multiplied by L multiplied by flux. Phi2 value is how much? Flux mu naught multiplied by N N1 multiplied by I1 multiplied by pi R2 square, right? Similar thing you are trying to do over here. So flux can be treated as how much? They are trying to ask you the mutual inductance, guys. If they ask you the self inductance, you would have written Li, but they are asking you mutual inductance. So I'm trying to write mutual inductance due to flux due to 2. So flux due to 2 will be equal to nothing but M multiplied by the current due to 1. That is what we have learned, right? So it will be nothing but M multiplied by current due to 1. You can very clearly see that the current and the current value are getting cancelled. We will be getting the M value, that is mutual inductance value, is equal to nothing but N1 multiplied by N2 multiplied by pi R2 square multiplied by mu naught multiplied by L. Can you able to see the answer? Is this comfortable to understand? So this is the correct answer. I think so. Sraba and Nandis have given me the correct answer. I want other students also to participate in these all things, guys. Just don't keep quiet and sit quietly and just think about that what to do. Okay, try to take some initiative that will really help you to understand the terms. Is it clear, guys? Is it clear? Is there any kind of doubt in this problem? Please let me know. Is this problem is clear to you? Let me know. So there will be more different kinds of problem that will be coming ahead. So don't worry, I'll be keeping one problem class only, in which we'll be discussing only questions, no concepts. Okay. Okay, good. That's really good, guys. So we're gonna move ahead with the concept of that is today's class. Okay, today's important class. So YouTube live students, are you understanding? Okay. Okay, so we'll be starting with today's class. That is, so I wanted to show you this video, guys, actually. So I think so I have already shared you this video, but I wanted to show to you. So you can see that due to the ED current, this magnet is going down slowly way, right? It was shared. Yeah. Good, Nandis. So due to the due to the property of ED current, this magnet is going down in a slow way, right? It is not going very faster. And this question only I asked you in the concept test that when ED current produce what? Tell me, ED current produce what? ED current produce heat. ED current produce heat. So that is the reason why you were telling the answer heat, right? Sir, if current passing through same coil means what will be the formula? If current passing through small coil, then what will be the formula? Monisha, it is not like that when current is passing through a small coil. See, it is like this. If current is passing through a coil, we're going to write E is equal to d phi by dt. E is equal to minus d phi by dt. So you know the formula E is equal to d phi by dt, change in flux with respect to 9. So you know the formula for current. Current is equal to nothing but, so you know, E is equal to, that is V is equal to I multiplied by R. So current value will be equal to E divided by R. So if you're going to divide this E by R, that means the current formula will be equal to nothing but E divided by R, which will equal to minus 1 by R d phi by dt. Is it understandable, Monisa? Is this understandable? So this is induced EMF. This is induced EMF. Induced EMF. And this is induced current. Just dividing it by, this is induced current. Is it clear? By a coil. This is the induced EMF that will be happening in a coil. So EMF produced due to the concept of Faraday. Faraday was the scientist. He told me about that. Okay, why EMF produced? Because if there will be change in flux, then with respect to time. So that is what I have written. A change in flux with respect to time is gonna give us EMF. Sir, light no production. No, there will be no light production. Okay, oppose the cause and heat. Yeah, very good, Nandis. Not life, not light. Good. Monisa, is this understandable, Monisa? This will be the formula. Is this understandable, Monisa? Can you able to join the dots? Is this understandable? Please let me know. Okay, guys, if you have understood this, then we can proceed ahead, and we're gonna proceed ahead with the LR circuit. So before starting the LR circuit, let me show you some common circuit. See, guys, why I'm teaching you LR circuit in this chapter is because next chapter you will be having different kinds of circuits. Okay, different kinds of circuit will be, you will be having R circuit. What do you mean by R circuit? Tell me. You have L circuit and you have C circuit. I want to show you something. That's why I'm asking you. So you will be having only resistance circuit. So R circuit means only resistance circuit. L circuit means only inductor circuit. C circuit means only capacitor circuit. Okay, so these are called, if a circuit is having only a battery and a resistor, then it is called purely resistive circuit. What you call? If a circuit is having only resistor, then it is called pure resistive. What you call? Pure resistive. Okay, if a circuit is having only resistor, then it is pure resistive. Very good. If a circuit is having only inductor, then it is pure inductive circuit. Okay, and if a circuit is having only capacitor, then it is pure capacitive. Okay, now there will be combination also. This is one type. There will be combination. So we have learned about combination of RC circuit, right? RC circuit, in which this is called RC coupled circuit or RC circuit, or there will be few properties based on. Resistor also produce heat in a very small amount. Okay, you taught about RC circuit. Very good. So I already taught about this RC circuit earlier, right? Good, Emma. So we have also, so in today's class, we'll be learning about nothing but a second combination that is known as LR circuit. That is known as LR circuit. Okay. And this RC circuit is generally used in most of the cases. LR circuit is also used in most of the circuit. And the third type of circuits can be LC circuit or CL circuit. Okay. So these is one of the these are some kind of combination. And let me tell you one more combination. So what could be the one more combination? Can you tell me which I have missed out, which I have not put it in front of you guys? Very good, Venkat. So the combination that is missed out over here is nothing but LCR circuit, a circuit that is having both resistor, capacitor, and inductor. So let me show you diagram, guys. I think so diagram will be looking good for you. So you can see when I talk about RC circuit, it is having resistor and it is having capacitor. When I talk about RL circuit, it is having resistor and it is having capacitor. And when I talk about RLC circuit, it is having resistor, it is having inductor, and it is having capacitor. And LC circuit is missing over here. Don't worry, we will be coming ahead. So these are the topics of your chapter number 7, guys. This is AC chapter, alternating current. In alternating current, you will be learning these things in a more deeper way. There are few properties of each and every circuit. Okay, this circuit will be having 3 properties. 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 Like that, each of the circuit will be having three different properties. Okay. Sir, new chapter. No, so this is not new chapter. This is the previous chapter, EMI chapter I'm teaching you. So in your EMI chapter, you have a small topic called LR circuit. And I'm telling you that LR circuit is the third part of this EMI chapter. Okay, is it clear? Amit, are you clear? Okay, so if this is clear, guys, then we can move ahead in understanding RL circuit. So our major concern will be nothing but RL or LR circuit. Okay, so when I talk about RL or LR circuit, first of all, let me tell you, this circuit will be having a kind of battery. Okay, circuit will be having a kind of battery. Okay, and this battery will be connected with a resistor. So first of all, I will try to connect this with a capacitor. So this is my capacitor, students. And this has been connected with a resistor. This has been connected with a resistor. And here I have one switch. Here I have one switch. So let me write down the switch as S, the EMF as E, the inductor as L, and the resistor as R. Right? So tell me, guys, if I try to close this switch, what will happen? If I try to close this switch, what will happen? There will be the maximum current? Will there will be maximum current from starting only, or there will be maximum current after some time? Deflection take place. No, don't think like that. Don't think like Pallavi. It is not there in textbook, but it is there in module, Pallavi. If you are trying to solve modules, it is there in module, right? So what exactly will happen? I am going to teach you over here. Understand it and write down the terms. So when you try to close the switch, what will happen? Current will produce from here, right? Current will produce from here. So current comes over here, current comes over here, current comes over here, right? So current come over here. Obviously, if this current is an increasing current, right? So there will be induced current generated over here. So actually, when you are having a circuit that does not have capacitor, so let me take a circuit which does not have capacitor. So I have a circuit over here. Okay, students, and this circuit does not have a capacitor. It have only resistor. What it have only resistor. So if this circuit is having only resistor, when I try to close the switch now, what will happen? The current value. Can you tell me the value for current? So the current value over here, I value will be equal to nothing but, tell me the value for current. It will be E by R, and E by R is the maximum value, right? This is the maximum current, right, students? So when your circuit is only having resistor and then you close the switch, the circuit will be having in starting only the maximum current. But when you are having a RL circuit, that means your circuit is also having a inductor. Okay, and you try to close the switch, that does not means that in starting, that does not means in starting the current will be maximum. So in starting the current will not be maximum. Is it clear, guys? Is it clear? Are you clear with this point? Is this point is clear? So at time t is equal to 0, your current is how much? Please tell me. Your current is how much? When time t is equal to 0, time t is equal to 0 means we have just started. We have just now tried to connect the circuit. Please tell me how much is the current value. At time t is equal to 0, how much should be the current value? Think and tell, guys. Nandi is wrong. Wrong, Amit, wrong. Nandi is wrong. So at time t is equal to 0, I'm telling you that when the circuit, when in a circuit, we are talking about only RL circuit, guys, not other than RL circuit. First, keep that in mind. So if time equal to 0, the current will be 0 because it is an inductor. There is an inductor. So in inductor, what happens? It does not take the current very fastly, right? Very good, Venkat. Very good. That is the correct answer. That's why I told you. Right, Anjal? Good. So at time t equal to 0, current is 0. If current is 0, can you tell me how this whole circuit will behave? In starting only. That in starting means on when you have just connected a circuit. If current is 0, how this circuit should behave? Very good, Venkat. So this circuit should be, okay. This circuit should behave like what? This circuit should behave like open circuit. This circuit should behave like open circuit. Okay, is it clear to you? Is this understandable? Are you getting the key points what I am trying to give to you guys? They will be like open circuit. Very good. So when you try to connect the circuit in starting and inductor is not charged and nothing has been provided. So at time t equal to 0, your current will be 0 and the circuit will be acting like an open circuit, guys. Now, if time t is equal to infinity, when I'm talking about time t is equal to infinity, infinity does not mean that he is going to infinity. Infinity only means that that is a maximum time the capacitor can get charged, right? Or maximum current he can induce. So at time t equal to infinity, can you tell me how much will be my current? So current will be equal to maximum current. Current will be equal to maximum current. So tell me if current is maximum, shall I say that maximum current is constant? Please tell me if current is maximum, shall I say the maximum current is constant? So if there is a constant current, students, will there is any role of inductor? If there is a constant current, will there is any role of inductor? Please let me know. Please let me know. There will be no role for inductor, right? Okay, just a minute. Yeah. So I was saying that if current is maximum, current become constant, then there is no role for inductor. So can you tell me? So this you called what? At time t is equal to 0, you call this is zero state, right? This is zero state. And time t equal to infinity is called steady state. So at steady state, how the inductor behaves? Tell me. At steady state, how my inductor is behaving, guys? Please tell me. Try to participate at my steady state, how my inductor is behaving. How it will behave? If there is no use of that inductor, then how he will be behaving? He will be behaving like a closed circuit or a short circuit. Very good, Soumya. He'll be behaving like a short circuit. Please write down these things. Don't expect me to repeat every time. Okay. These are the key points that is necessary to you guys. And it is really mandatory to understand the thing. Is it clear to you? Have you got a little bit idea about LR circuit? Are you getting information about LR circuit? So the information that time, sir, how short circuit, sir? See, Venkat, when the current become maximum, so current have become constant, right? If the current become constant, so there is no use of inductor. So remove that inductor. So if I remove that inductor, then what will be there? Please tell me. So there will be only normal wire, right? There will be only normal wire. So if there will be only normal wire, what I say normal wire? I say normal wire as short circuit. Is it clear? Is it clear, Venkat? Is it clear? If you want, I will write it down for you also. Okay. Clear, right? No confusion. Now. So you can replace. So In zero state, guys, you can replace this inductor from open circuit. In steady state, you can replace this inductor from short circuit. Very mandatory point, and these are the key points that you can expect in EMI chapter. They can ask you question. Okay, guys, these are the key points they can expect. Please inform your friends to join the class. Still, I can see that I expected more number of students to be there in class. Okay, if it is clear, guys, now I'm gonna teach you one important property over it. Understand it? Now you will be getting. Okay, so we have something called current over here, right? So what is happening to current? If so, I got to know that when time was zero, my current was zero, right? And when time is infinity, my current is maximum, right? Maximum, that means it become constant. So where is the use of inductor then? Where is the use of inductor? Please tell me. And when time was zero, there was no current, only inductor was behaving like open circuit. When time become infinity, the current become constant, inductor is behaving like a short circuit. So where is the use of inductor? The main use of inductor is between the time t equal to 0 and t equal to infinity. Between the time t equal to 0 and t equal to infinity. Okay, between this time. Is it clear, guys? So between this time you will be going to say that inductor is gonna work, right? So what do you guys can think, what inductor can do between this time? Means according to your thinking, what inductor can do between this time? Means from 0 to maximum, what he can do? Please tell me. Resist the change in current. Okay, that is a correct way of understanding. Other thing, sir, here steady and zero state is opposite to capacitor steady and zero state, right? No, 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 no. It's not like that. Zero state means time t equal to zero. Keep that in mind. It is not opposite, Amit. You need to keep this in mind. Zero state means very clear that time t equal to zero. Steady state means very clear that you have already went for a very longer period of time. So what will happen? Okay, one of your friend is said a very correct thing, Nandis, that heat will produce. Yeah, obviously heat will produce. That is one of the point that you can say. Other points, guys. Change in current, right? So most of the students are saying that in middle, what is happening, right? In between, there will be change in current. Will be change in current, right? There will be change in current. Up now, if everyone is clear till here, no confusion, right? Amit, don't copy paste the same thing. Don't copy paste the same thing from RC. You told me that it is interchanged, right? So this is steady state. This is zero. I am teaching you that don't, you cannot change the name. You cannot say t equal to zero at steady state, and you cannot say t equal to infinity at zero state. Okay, that is what I'm telling you, Amit. I'm not telling you that they will be same. Okay. Sir, in eddy current, charge gonna waste now in form of heat. So how to overcome this? We can't overcome actually in this. That is one of the disadvantages, and due to that only heat produce, and it goes out in the form of heat energy, and we can't conserve that heat energy, right? Okay, Amit, got to know. Okay, no problem. So there will be change of current, guys. There will be change of current. So can you tell me change can be in what format? It is used in iron, copper. Can you tell me change can be what? Change can be either negative or positive. That means that is what I'm teaching you from the, I think so, from RC circuit. So either, so there are different names of thinking about it. Okay, so in the RC circuit, we were telling charging, discharging. In the LR circuit, we will be not saying charging, discharging. We will be saying growth and decay. So we'll be saying growth, and we'll be saying decay. Okay, be familiar with these words, because these words are gonna very familiar with, you're gonna needed to be familiar in the last modern physics chapter, right? Okay, good. Okay, so we will be having, so this change of current either lead to growth or growth of the current, or either lead to the decay of the current. Growth is also treated as somewhat charging. Growth is also treated as somewhat charging. That was there in capacitor. I'm trying to correlate the points. And decay is also treated as discharging, guys. Is it clear to each and every one of you? Are you guys are clear till here? So this is the formula for charging, guys. This one is the formula for charging. Let me tell you. This one is a formula for charging, and we're gonna derive it. Why it is very necessary to derive? Because lots of questions are based on derivation only. Okay, they don't ask that this is time, this is register, then get me the answer. No, they're gonna make the questions in such a way that they ask in a pretty difficult term. Okay, so that's the reason why we are going to derive. Okay, derivation is not tough, only just a small integration you need to understand. Okay, so let us move ahead, guys. Let us move ahead with the growth first. So we'll be talking about growth. Growth means charging. Okay, please don't treat growth as some different kind of word and think that, oh my god, this is something different, I cannot understand. If you have understand the charging discharging of a capacitor, then growth and decay of a LR circuit is very easy term. When I talk about charging, so let me take a circuit. Okay, this is my circuit, students, and there is an inductor over here. Okay, and there is a resistor over here, right? And this circuit is closed, and there is a EMF over here. This is L and this is R. You can see that the induced EMF will be there in opposite direction. The current will be flowing in this direction. Everyone is clear till here, right? So what we're gonna do is we're gonna apply KVL. We're gonna apply KVL. So Monisa, you were asking me about this. I was also not telling you about this in last class. The reason because I have not taught you about the KVL of LR circuit, right? So you can see the how the battery is behaving over here, right? Kirchhoff's voltage law. So how the battery will be behaving over here? See, the induced current is going like this. So obviously there will the positive terminal will be here and the negative terminal will be here, right? So this is how it will be behaving, the positive and negative, right? That is the reason why induced will be going over here. So we are gonna apply KVL. So let us move in this direction. Okay. So first of all, we are coming outside from the positive terminal of battery. What shall I write? Shall I write plus C or shall I write minus C? Please tell me. So I'm gonna write A B C D. A B, C, D. So I am taking the loop A, B, C, D, A. So I'm moving from A to B. I'm coming outside from the positive terminal battery. Shall I write plus or minus? Very clear to understand that I should write plus, right? So I will writing plus E. Then I'm moving from B to C. There is nothing in B to C. Then I'm moving from C to D. There are two things in C to D. As you can see, first of all, the current the current in the circuit is flowing in this direction. The current in the circuit is flowing in this direction, but the induced current in the inductor, this is induced current, guys. This is induced current. The induced current in the inductor is flowing in opposite direction. So you are coming outside from in inductor, you are coming outside from the positive terminal battery or the negative terminal battery. You are going from C to D, guys. In the inductor, are you coming outside from positive terminal or negative terminal? You are coming outside from negative terminal, and that is the reason why we are writing minus L di by dt. So we'll be writing minus L di by dt. Are you understanding why I'm writing this minus sign? Are you understanding why I'm writing this minus sign? I hope, Monisa, you have also understood this, right? So this was the doubt you were asking, sir, why we are writing minus sign. So I cannot make you explain in last class, right? The reason because I have not made you understand these terms. You know these things, but you have not implemented it, so it will be tough, right? Now you know and you can implement it. So you can see that I'm trying to apply KVL and L di by dt. This is only the formula for EMF, right? L di by dt, right? Mod formula. So if we are coming out from the negative terminal of the battery, so that's the reason why I'm writing minus L di by dt. Now again, I'm going in the direction of current. I'm going in the direction of current. What should I write? What should I write? Shall I write plus IR or shall I write minus IR? Please tell me, guys. I'm going in the direction of current. Shall I write plus IR or shall I write minus IR? So it is very clear that I should write minus IR. So I'll be writing minus I multiplied by R. So inside this loop, this whole value should be, the KVL should be equal to 0. Is it clear? So you're gonna write E. So I will try to resolve this. This is the equation you need to understand how to write. If you remember this equation, then you can solve each and every problem. If you don't know how to write this equation, then it will be really difficult to solve problem, guys. So it is really mandatory to write this equation. So but actually the formula is minus L di by dt. So minus of minus L di by dt. So it become plus L di by dt. No, 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 no. It's not like that. It's not like that, Monisa. So formula is minus L di by dt. That is with respect to the direction. Okay. So we are taking mod. We are taking mod. That is why reason why we are while solving problem we were taking mod. Is it clear? So minus sign is only representing the direction of the induced EMF. Are you getting my point, Monisa? It is not giving you that whole inductor is only reversed. Are you getting my point? So minus sign is only representing the direction of it. So you can see over here. So positive area, right? So don't get confused over here, guys. Okay, so you can write E minus IR value should be equal to nothing but L di by dt. L di by dt. Now you need to do the integration over. Sir, Venkat, I have just discussed about the growth of the LR circuit. Okay, no, not more than that. Okay, Venkat. So what I can write from here? I can write nothing but see. You're gonna proceed from here. That is, you have to do integration. So you cannot remember this integration. So you can try this integration. I have this. This is my whole factor, and this is my whole factor. I cannot directly do integration over here, right? So let us try to do cross multiply. So what I'll be drawing, I'll be writing dt divided by L should be equal to di divided by E minus IR. Dt divided by L should be equal to di divided by E minus IR. Are you getting my point? What I'm trying to do? I'm trying to bring this current with the current term and dt with normal L. L is nothing but constant. Anjal, sir, E plus IR is equal to V. That is for the battery. I'm not talking right now for battery, right, Anjal? This is inductor. I'm trying to apply KVL. Is it clear now, Anjal? So this is what I'm trying to apply KVL. I have taught you how to apply KVL, guys. I've taught you two different methods, out of which we generally use one method only. If you're coming outside from the positive terminal battery, we will write plus A. Done, right? Good. So once we have reached till here, dt by L, you can see dt divided by L should be equal to di divided by E minus IR. I have just tried to mismatch this, right? Now I will try to do integration. Now I'll try to do integration. So guys, the first integration is with respect to the time. So if time t is equal to 0, can you tell me how much is the current? If time is equal to 0, current is how much? Tell me, students. So if my time is equal to 0, my current is 0. If my time t is equal to infinity, or instead of writing time t is equal to t, so we'll not gonna write time t equal to, we'll write at time t equal to t, my current is gonna be how much? Current is maximum. So let me write I. Okay, let me write I. Now you have to do integration. So can you tell me what is the integration of dt? So everyone knows. I will write down the integration over here, guys, for your sake of reference so that you understand it. So please tell me what is the integration that is going to happen. So what is integration of L is a constant term. Integration of dt is nothing but t only. So integration of dt is nothing but t. So it will become nothing but t by L, right? Should be equal to, this value should be equal to integration of di. I need to do integration. You can see that you have one I term in denominator also and in numerator also. So you cannot direct do integration. So you know what is integration of 1 upon x. So integration of 1 upon x is nothing but log of x. Over here, I have integration of 1 upon e plus ir, right? So what will be the integration, guys? So integration will be nothing but you will be writing log of, tell me. So you'll be writing e minus ir divided by e minus ir divided by, please tell me what we need to do. Then we have to do differentiation of E minus IR. So what is the differentiation of E minus IR? So E is a constant term. Differentiation of IR is nothing but only minus R. So we'll be getting minus R. Is this integration is clear to each and every one of you? Why, Nandis? Why haven't you tried to solve integration in chapter number when Vishal sir tried to taught you? Good, Srava, good. Right, so it's a easy integration. Don't worry. Try to go home. Ask, take help of your friends also. If you are feeling that you are trying to face some kind of difficulty in integration, guys, feel free to ask me. Feel free to ask your friends. Right, take the help of your friends to grow. Don't be like that. Ki friends are just friends. Okay, use them to grow yourself. Don't just be like that. Okay, so you're gonna write t by L is equal to log of E minus R, and you have to put the value from where to where? Value from 0 to I. So if you're gonna put this value over here, you're gonna get nothing but, I'm gonna write, you're gonna get C. T by L is equal to C. So you have nothing but minus 1 by R. You have log of E minus IR. And the value you need to put is nothing but from 0, I'll try to write it down in this format. From, I'll use blue color so that it looks good. So from 0 to I, right? Now T by L should be equal to nothing but minus 1 by R. So tell me, if I try to put the value for log I, so it will be nothing but you will be getting log of E minus IR, then minus of log of, so if you put the value instead of I, if you put the value 0, you're gonna get this value only 0. This value will be there. So you'll be getting log of E. Is it clear? Is it clear? Now you try to solve this, guys. So T by L is equal to nothing but minus 1 by R. You'll be getting log of E minus IR divided by E, right? So we'll be getting this. Because log A minus log B is log A by B. You know this formula, right? So we'll be writing minus 1 by R log of, so I'll be replacing this. I'll be writing minus RT by L, minus RT by L. Can I write like this? I've tried to cross multiply this R to the left hand side. So minus RT by L is nothing but log of, I can write 1 minus IR by E, 1 minus IR by E. So if I try to solve this, what can I write? From here, the step goes like this, guys. So if I try to solve this, I can write 1 minus IR by E can be written as e to the power. So see, I'm trying to use anti-log property, guys. What I'm trying to do is I'm trying to use the property of anti-log. So e to the power, how much it will be? It will be e to the power minus RT by L. Minus RT by L. Very mandatory to understand, guys. This is the important point that you need to be keeping in mind so you can easily solve them. Right. So what you can write from here, you can write easily from here that minus, sorry, if I replace this minus, I'll be writing IR by E can be written as 1 minus e to the power minus RT by L, right? 1 minus e to the power minus RT by L. Sir, is there any new batch launched for class 12? No, Ramesh. There is no kind of new batch. Why you want new batch, Ramesh? Are you left out with some topics? Is it like that? Okay. Okay, don't worry. Just because you have a sake of reference of learning again, you are trying to miss these things, whatever you are learning now. Because whatever thing I'm teaching you, I'm not trying to make you correlate with the previous things. That is the beauty of it. Okay, so learn now. Whatever the left out terms, when we'll be doing revision of class 11th, it will be helpful for you. Okay. Okay, so what I can do over here, guys, I can do, so I can write I is equal to nothing but E by R. So can you tell me what is E by R, guys? Can you tell me what is E by R? What is E by R, guys? Please tell me now. E by R. So voltage by resistor is known as current. That is what you have learned in chapter number 2. So this value is nothing but, so I'm going to write it over here. So we'll be getting I is equal to I naught multiplied by 1 minus e to the power. So let me tell you one thing. Minus t by tau. What we'll be getting? Minus t by tau. What is tau over here, guys? So actually the tau value is nothing but L by R. What is tau? Tau is called time constant. So there was time constant in RC circuit also, guys. So that is just a correlation, okay? So this is called time constant. Time constant means this is the time that is required for the LR circuit. So tau is equal to L by R, and I'm going to write nothing but I is equal to I naught 1 minus e to the power minus t by tau. Is it clear, guys? There will be Avanti classes, USA. There will be Avanti classes. See, relaxation time or time constant, you can say like that. Yeah, good, Arun. Good. That is correct. Ramesh, are you understanding, Ramesh? This is comfortable to understand, Ramesh? Don't worry, Ramesh. See, if you feel not understanding anything, feel free to ask. I'm always there to be there to help you guys. But if you're not asking only, then if someone is there already for your help, he or she. Sir, after that log, log set, I did not understood. After that log, this, after this, are you talking to me after this? Is it till, is the integration part is clear? Sir, what is I naught? I naught is a maximum current. I naught is a maximum current, or you can write I max. Okay, I max is the maximum current. I max value, you can see it is value, it is equal to E by R. Sir, integration part, Amit, I will tell you, just stay in the class. I'll let you know about integration. I don't know why you don't know this integration. I cannot teach you every time integration, guys. I have already took you 2 classes for integration. I made you understand these are small integration. This is the chain rule part. This is one of the part of chain rule. Okay, I can teach you at the end of class. Okay, sir, how we get E? So actually, when there is suppose 2 is equal to log 10. Okay, log, so log e base 10. So you can write, suppose 2 is equal to log e base 10. You can write 10 is equal to e to the power 2. Is it clear? Is it clear? Is it clear, Amit? So you over here, the thing that was written over here is, see, they have written RT. So minus, so they have written minus RT by L, right? Is equal to log of something. Suppose log of X. So I can write x is equal to e to the power minus RT by L. Is it clear? Yeah, you will be using this formula. You will be using this formula. Is it clear, Amit? Amit, is it clear now? Okay, good. So basically for a RL circuit, that is LR circuit, if they are asking you for the growth of the current, they're asking for the growth. Growth means charging. Okay, growth means charging, guys. So they will not write directly growth, guys. They can also write charging. Okay, so if they're charging, then the current value will be equal to I is equal to I naught 1 minus e to the power minus t by tau. That is what we have derived it over here. I is equal to I naught 1 minus e to the power tau. It is very easy to remember the formula for charging and discharging. So for charging, I have remembered it like this, guys. For charging, my formula is I is equal to I naught 1 minus e to the power minus t by tau. So can you tell me what is the formula for discharging? If you can tell me, it is very comfortable to remember, guys, for you for a longer period of time. Participate and tell me. So for discharging, the formula will be opposite. The formula will be opposite. No, plus minus. The formula will be opposite, guys. So for discharging, the formula will become nothing but I is equal to I naught. Only you will be not having this one. This term will be cancelled out. E to the power minus t by tau. Is it clear? For discharging, you will be having only this term. Is it clear, guys? I hope you are getting, right? I hope you are getting, not from negative to positive, guys, not from negative to positive. So I hope this is the way of remembering the things, guys. Every formula you cannot mug up in the exam and go. You need to have some kind of correlation with the formula. I can teach you hundreds of formula. Sir, it is meaning that charging plus discharging is equal to 1. You can say like that. You can say like that. Charging plus discharging is equal to 1. You can say like that. But this is the better way to remember. Even in RC circuit also, I made you this technique only to remember, right? So you can very easily comfortable say and tell me about this point. Is it clear, guys? So I'm keeping one question in front of you. Will you try to solve this question? I'm keeping one question in front of you. Will you try to solve this question? Find the current I1, right? So this is, there is a circuit in front of me. You can see the circuit. So the circuit is having 10-volt battery and 2 ohm resistor, and then I have 3 ohm resistor, and I also have 6 ohm resistor and a inductor also, 2 Henry. Okay, I also have an inductor also over here, right? So this is my inductor, guys. So please tell me, this is 6 ohm and this is 3 ohm, and the current over here is I1, and the current over here is I2, and this is 2 ohm. So, and this is 10 volt. They're asking find the current I1 and I2 initially when the circuit is closed. So when circuit is closed, so circuit is closed at what time? Sir, hint, circuit is closed at what time? Time t equal to 0. So at time t equal to 0, how the inductor behaves? Please tell me. At time t equal to 0, how my inductor behaves? How my inductor behaves? Please tell me. You know the answer. You can try it out. Open circuit. So what I need to do? My inductor behaves at time t equal to 0 as open circuit. So you can actually replace this inductor. So you can see that there was 600 inductor over here. You're going to replace this inductor and you make it open circuit. What do? You make it open circuit. Now, is it easy to find the current I1 and I2? So it is easy to find, right? You can see the current. So don't give the answer in that random ways. So current I2 will be how much? Tell me. So you can see since branch 6 ohm branch is having open branch, so current I2 will be equal to 0. How much will be current I1, guys? You can find it out. Everyone know how to solve this. So this is 3 ohm, this is 2 ohm. So total resistance is 5 ohm, right? So this is just looking like a circuit which is smaller in shape like this. Can you see? This is your 5 ohm, that is 3 ohm plus 2 ohm, right? And this is your 10 volt. So current is how much? So you can see current is equal to V by R. So it is 2 ampere. Is it clear? So I1 will be equal to 2 ampere. So when you have just connected the circuit, when you have just switched, so you can see how they have written. Initially when switch is closed. So initially when switch is closed, the current is, I1 current is 2 ampere and I2 current is 0. Is it clear? Now, after steady state, there is one more question, guys, they are asking. There is one more question they are asking. Okay, so after steady state is achieved. So once steady state is achieved in LR circuit, how current behaves? Tell me. If the steady states have been achieved in LR circuit, how my current behaves? You know the answer, guys. So you know that if steady states achieved, the current becomes constant, right? It become maximum, and constant, right, students? So constant means how does my inductor behave? Please tell me, how does my inductor behave? So if current only become constant, then there is no use of inductor. So inductor will be acting like a short circuit. Short circuit. Is it clear to you? Is it clear to you? So you're gonna replace maximum. Yeah. So maximum current should flow, right? So you're gonna draw the circuit again. See, the circuit goes like this. So there is resistor over here. There is one more resistor over here, and this is connected like this. Now there is one resistor over here. Now instead of this inductor, I will be doing short circuit. I'll be doing short circuit. Is it clear to each and every one of you? This is 6 ohm, this is 3 ohm, and this is 2 ohm. Now you know you can easily solve this circuit and get me the value for I1 and I2. Right? You can easily solve this circuit and you can get me the value for I1 and I2. So I'm not asking you to find the value. Try this in a homework. Get me the value for I1 and I2. I will ask you in next class. Okay. So what is left out, guys? Tomorrow's class, what we'll be doing is we'll be trying to understand the LR circuit, that is growth. We have not talked about decay, guys. So we'll be talking about decay, LR circuit decay, and we'll be also talking about the few questions, guys. So from tomorrow, so there will be two more class, guys. Three more class. Okay, there will be three more class for EMI. One class will be there for decay and few questions of this topic. One class will be previous year JW and NEET questions, and one class will be again questions only. So we have, I think so, we have not done lots of questions from module. So I also want you to solve the module questions also, because I'm seeing that most of the students are like, if I'm not solving modules, they're also not solving module. And it should not go like that. Good, Venkat, good. So guys, I'm launching poll. Everyone try to answer this poll. Is the class was understandable, and could you able to understand LR circuit today? The basic thing that you should understand from today's class is you should understand that how the LR circuit behaves when time is 0 and when time is infinity, and when it becomes steady, how it behaves. I have took only one vaccine, Angel, not more than one. I still have to wait for second dose. I think so. So everyone try to answer the poll. Utilize students, are you understanding? Sir, when current is increasing, oppose the growth of it. Very good, Sahil. Are you understanding, Sahil, right? Are you understanding, Sahil, right? I hope you guys are understanding the class and it is really helping you. So make sure you attend the class on regular basis, guys. It should not be like that class is not being attended on a regular basis. Okay? Okay. So we'll wind up for today, guys. We'll meet you there in next class. Please make yourself comfortable and be there. Thank you. Thank you. Thank you to each and every one of you guys. Thank you. Thank you.